How's it going, YouTube? Don here. In this video we're going to do number 152, maximum product subarray. So this is a problem off the blind 75, and I thought today we just do it in Swift. I don't see a lot of Swift tutorials, so here you go. So given an array integer array nums, find a contiguous non-empty subarray within the array that has the largest product and return the product. The test cases are generated so that the answer will fit in a 32-bit integer. A subarray is contiguous subsequence of the array. So we can see here nums 2, 3, 2, 4, and then 2, 0, 1. So you can see here that the subarray, largest subarray is 6, which is going to be these two elements, right? So, and then we see the second example that it's basically going to be 0 because we can't have these two elements because they're not contiguous, right? Otherwise we'd be cheating. We'd do like 2, 3, 4. We'd be like cherry picking values. That ain't good, and that's not what we want. So how do we do this? Well, first thing is, let's try the naive solution. So what if we took 2, then we multiply that by 3, then we multiply that by 2, we multiply that by 4. Then we move over to 3. We get 3, then 2, minus 2, and then 4. And we do the same 2, minus 4, and then 4. But that's a really messy solution, and that has a terrible time complexity, an O of n squared time complexity, right? Definitely not something that we want to do, but it's definitely a good start, right? So how can we do better? Can we create a solution that's in O of n time? How do we do that? Can we use a hash map? Probably not. But what we can do, and this is a neat little trick here, what if we multiplied all the values inside of the left-hand side? Let's see what happens from there, right? Let's try that. So what if, so 2, we have 2 times 3 is 6. We have 6 times negative 2 is negative 12. Times 4 is negative 48, right? Alright, so what do we do now? Well, let's try to multiply the right-hand side. So this is basically like prefix, suffix. So we got 4. We got negative 2 times 4 is negative 8. Times 3 is 24. And then times 2 is negative 48, right? It's very similar to the strategy, I believe it's called sum of all, or multiplication of everything except itself, something like that. Very similar thing, and I just happened to try it with this problem, and it worked out very well. So we use the same concept. We're going to call this left and right, and we're going to call it the answer. And basically what we're going to do is we're going to compare the two values as long as with the current answer value and see which one's greater, right? So here we have obviously 2, and we go here, we see that it's 6. We compare 6 to negative 12 and negative 8, we still get 6. Then we compare 6 to negative 48 and 4, and we still get 6. And that's what we're going to return. That's what we see here, right? And then now let's try that with the second one. We'll go left and right and A, which is the answer. So what we're going to do here, oops, I should change color of that. Alright, so we got negative 2, 0, and then negative 1, right? Or 0 and 0. My bad. And then we do it the same on the left hand side, so it's going to be negative 1, 0, and 0, right? And what does that result in terms of our answer? Well, we have 2 and negative 0 is going to be 0. This is going to be 0. And this is also going to be 0. So obviously we're going to return 0 here. Now that's fine and dandy and all, but there is an edge case. Pause the video and try to think of it. So, what the edge case is what if we have a 0, but one of the values in our array is actually a number that's the greatest sum. So let me give you an example here. What we're going to do is I'm going to show you this example here where I have 3, 0, 1, and -2. Now just looking at it, you can see here that we want to return the sum, but if we use our formula here, then we see that it's going to be zeros all around. So how do we change this? How do we modify this for this particular example here? What if instead of 0, we replace this with 1, right? Since 1 is the greatest one in the array, what if we, every time we see a 0, we replace that with 1, right? Now in that case, let's just say 3 and 0, or 3 and 1 now is 1, then we have 1, then we have 1, and then we have 1, right? And 1's going to be our answer, right? So that's going to be one of the edge cases, and that's something that we have to deal with, right? Or actually, we're only changing these ones because you have to leave the 0 here because it is 0. But let's code it up. So the first thing is, what if we have a array that looks like this? What if we had like a 0 or something? Well, we had to prevent that. So guard nums.count is greater than 1, else we return the first index in nums, right? That's going to be our answer. So what we do is we set a var of answer is equal to nums 0, and then we set a var left is equal to 1. Since we're taking the maximum product subarray, it wouldn't make much sense to actually multiply it by 0 because you're going to get 0, right? And var right is equal to 1. So for I in 0 dot dot nums dot count, and then what we're going to do is we're going to have left multiplied nums of I, and then we got right multiplied of nums starting from the other side. So we're going to have nums.count minus 1 minus I. So we go this way, right? And then, whoops. Lastly, we're going to take our answer. And the answer, you could also represent it as, I just like doing the first index, because you never know if it's all negative numbers. You definitely don't want to use like negative infinity, for example. So using the first index is always a safe bet because you always end up taking the maximum product subarray anyway. So that's kind of why you want to do that. So max of ants left and right. Now let's handle our edge cases where your left is going to be 0 and your right's going to be 0. So if left is equal to 0, we're going to left is equal to 1. And then we have if right equals 0, right is equal to 1. So we just basically use this to handle our handle our the 0, such as in this case, in order to process the actual maximum in this particular edge case, right? So lastly, all we need to do is we're going to return the answer. So let's submit. And that worked. Let's submit again. And we can see here that it's a pretty efficient solution. We can see here O of n. We did not use any extra space, so obviously this is going to be an O of 1 space complexity. So if you guys enjoyed the video, don't forget to hit like, comment, subscribe. Let me know in the comments if you want me to do more of the Blind 75 in Swift, and I'll see you next time.